I actually banged it first time, now I can't even do it.
Start off from my verse 1, 2, 3 into the 4, starting with the naturals, but we've got more to explore. Ready for mathematics, so listen close, and you might want to go make some notes. The definition and conditions for the naturals. They are the positive whole integers, you know that's factual. So those lyrics there, pretty self-explanatory really. All it is I'm telling you what the natural number set is. That's what my verse is pretty much about. There's just all the different number sets that be used in mathematics. So for all those non-specialists out there, I'm giving you like a little insight onto like the start up and the beginning of mathematics. Next lyrics we go. But we got to go and ask what's net x, then we got the integers and rational set x, can't forget about real and complex x. It's not easy, so you might become perplexed. So what I just did there was I just kind of gave you a little forward insight to what else we're going to be talking about, the other number sets, you know what I'm saying? So back to the subject at hand, integers are the whole numbers, I hope you understand. That's all the naturals and negatives, including number 0, but talking sets we've got more to give. And what I just did there was talk about the integers. So with the natural numbers, the integers include those numbers, but we include the negative numbers as well, so the negative naturals. But then we also got to include 0, which isn't negative and it's not positive either, but we've got to include it because that is a whole number. So on to the next, because then we move on to the rational set, the fractional set, which includes the wholes and the natural set. So the rational set is the set of all the fractional numbers, and that can be like a whole number, like 0. Now we move on to what's real, which in mathematics, this set is truly ideal. But when we're talking about number sets, we got to make sure that we talk about the complex. Alright, so this, all it is we got the number sets. And when I say most ideal, it is usually the real. Nice rhyme. But that's because the real is what we use all the time. It includes the rational numbers, integers, whole numbers, the natural numbers. It includes the irrational numbers like pi, the numbers that never end, almost the perfect set, but it's also missing something.
Maths is pretty simple, but this right here is complex. Started with a natural, now we're on a new set. You see, everyone knows about natural sets, the integers. Everyone knows about those, but not many people know about the complex numbers. You see, complex numbers it's a combination of real and imaginary parts. Like, obviously, you got the I, which is square root of -1. I obviously talk about that in my lyrics and that, but not many people know about it. Just like, it's a shame, to be honest. See, I'm trying to be the greatest like Euler, and this right here I'm about to say was spoiler. Because square root of x squared plus y squared is r, and r is the modulus. It tells you how far. Now, you see, when you got your equation, z equals x plus iy, to find the modulus, all you need to do is square root x squared plus y squared, like you would do in a normal circle. Now, z is x plus iy, but forget what you know, this ain't the last time. The x is the real and the y is imaginary. Wait, don't be alarmed, I'll explain, just let me. Alright, and obviously, in complex numbers, you got the real and imaginary part. You got different forms of them, you got the different ways of them. Obviously, x is real, so you just got like numbers like 1, 2, 3, 4, 5, all of that. And then y is like the imaginary part, so obviously got like I, 2i, 3i, 4i, minus I. Wait, don't be alarmed, I'll explain, just let me. Imagine the square root of -1 and we call it I. Yes, I, but we change form, that's an I for an I. See, z is the e to the I pi. I got so many identities, you'd think it's a crime. Like r cos theta plus I of the sine. We could go on, but it'll be kind of long. So I'm going to leave you with e to the I pi is also -1.
So when making the track, kind of worked his 2 songs into one.
And to be honest, the lyricism you're about to hear could have been written by Jay-Z. It's that good.
Pick up a pen, write about sins. Now, cause man, I'm about to go on a tangent, vector show away direction. So, sine, cos, tangent in the first 2 lines works as a trigonometric function. Tan and tangent, you know, they work as 2 different things. They're defined as 2 different things in maths, and then also the English term tangent when you go off on something else. So yeah, that's what it was about. I kind of led, you know, the listener to believe that I was going to talk about trigonometric, whereas I'm not. Vectors show away direction. You know, it's just how vectors are. They do show direction. They also show positions of stuff. They show quantifiable amounts of things. So yeah. A to B and C to D, coordinating my way around these verses to make it clear to you the position that is taken down. Dimensional, talking about planes, is it 2 or 3, are flying around these words like I'm in X, Y, or Z. With this one, flying around like planes, not actually vector planes, but it's just a play along words. So like a plane is in you're flying like an aeroplane. Like I'm in X, Y, or Z. So in the 3-dimensional plane, you look at the X plane, the Y plane, and the Z plane. Yeah, and dimensional talking, 2D or 3D, you know, most of you guys will probably be introduced to 2D vectors, but, you know, as the maths progress, you get introduced to 3D vectors a lot more. Start at point O and get point P, originally we see. Then you can figure out the magnitude by square root in the square of A plus B plus C. That's pretty self-explanatory. With the magnitude, that's the size, and you square root A squared plus B squared plus C squared. Line, equation, creation, get 2 coordinates and assemble, find the distance between the two to get a direction and the scalar. It's just speaking about vector lines, something that you do get introduced into further maths in A level if you're not aware of it. And that includes a scalar, a position, and a direction vector, sorry. So that allows you to figure out what the line of the equation is for the vector. With that and a position on the line, you get the equation. So 9 to the O, keep it 8 more than 82. You can find vectors perpendicular if the dot product is 0. Right angles in vectors like normal, they're clear cut, like the tangent I've just been on the plane that we're on. So yeah, you can have tangent planes as well that you learn further on into vectors and stuff like that as it gets advanced.
These last 12 bars basically go over most of the topics that haven't previously been discussed, such as planes, commutativity, associativity, intersections. So let's get right into it. Spot intersections is plain to see, 1 point share between all 3. I'll cross you like 3 planes, we have nothing in common. So these first 3 bars reference intersections of planes. The first situation, we have 3 planes and they all intersect at 1 common point. So you could have plane here, plane here, plane here, and then there's this 1 common point that they all intersect in. And then the second situation is when we have 3 planes, but they don't share a common point, while simultaneously all intersecting. So for example, you can have a plane here, and then a plane here. 1 crosses like that, 1 crosses like that, 1 crosses like that. So they intersect each other at 3 different points, but none of these points are common between all 3. It's u v me, get out my vector equation. I only take w's, you know I stay associative, scaling up to the top by being commutative. So u and b are commonly used to denote vectors. You can have w, I mean really you can take anything, but u and b are most common. And basically u, v and w are associative when we have brackets, u plus v, close bracket, plus w equals u plus open bracket, v plus w, close bracket. The final line discusses the fact that a scalar product is commutative, which means that u dot product of v equals v dot product of u if u and v are both vectors. Everyone knows my identity unlike this product of 2 vectors. If one's 0, you're out of luck. Read between the lines from a different angle, side by side and parallel, never going to tangle. Scalar products basically don't have an identity, which means that if we take 2 vectors and we take the dot product between them, then you're never going to get a vector as the outcome. And the side by side and parallel line is discussing 2 parallel lines and the fact that they're never going to intersect at any point because they share the same direction. Now that I've told you about these vectors, these skew lines you'll recognize in your lectures. After hearing this rap, you should feel absolutely enlightened about vectors.
I think some people look at maths and they don't really enjoy it. Whereas for us guys, we kind of see the more interesting side of it, and that's why obviously we do it at university and stuff like that.
The music's just gonna have a meaning to it now. The music just have to meaning, like, we just need to show people what they can do with stuff, how they can use their brain. We just got to show people.
You know, everyone played their part in the music and it was pretty sick. So yeah, I think we're excited to, you know, to see that it's doing very well.
Just like my success, ha ha ha. Yeah, so peace out, ha ha ha.